looking at the buck converter, which is drawn here, and we're looking at how to size the inductor value. To do this, we need to look at the inductor current, which you could visualize right here over one period while the duty cycle of the active switch is on, up to here, and then after that the switch turns off. So if you look at this current I've drawn, it is in boundary conduction mode, if you remember, BCM. And this is where we want to calculate the inductor value. If we calculate the inductance at this value, this is called the critical inductance value. So first, we assume let's operate in BCM, and let's find this inductor value that exactly fits this. So we're going to start with looking at just this period. So when the active switch is on, we'll calculate just the going up part. And what we need to know is we need to know this value. This is I peak. And I peak is going to be 2 times the average value of the inductor current. So 2 times delta IL. If we look at this, we notice that the inductor, the average inductor current, is the same as the average output current. This is because the average current through a capacitor must be 0. So this average current will be 0. So this average current and this average current are the same. So then we know that actually this is going to be 2 times the output value. And I'll just draw, we know it's going to be right in the middle. This is going to be the average output value. So now we know all the points. We know the peak value, we know the period that it's on. Now we can use the inductor value to calculate this inductance. So we can say, what is the voltage over the inductor during this phase? We know it's going to be V in minus the average of V out. That's going to be equal to L. The change in the inductance is 2 times the average output current. And then the time here is dt right here. So now we can just solve for L by rearranging this equation. Okay, this is actually the basic form of what we call the critical inductance value. And if we know our load, here our load is a resistor, so we know that, for example, I out will simply be the average of the output voltage divided by the resistance. So you can calculate all of the intermediate values like the output voltage, output current, and then plug them into here to get this critical inductance value. If the inductance value that you choose is equal to L crit, as we just showed here, it's operating in boundary conduction mode, BCM. If we choose a value, an inductor value that's higher, this is going to lift off, it's not going to touch 0, it's actually going to be in CCM, continuous conduction mode. So if L is greater than L crit, you're in CCM. And conversely, if you pick an inductance value that's lower than L crit, you will be in discontinuous conduction mode. So generally, if you want to design for CCM, you can calculate this critical value and then pick a value that's going to be higher than that, and then from there you can figure out exactly how much ripple you would want in your inductor.